Hi, and welcome to Jim's radio shop. I'm going to be firing this radio up pretty soon, and I thought I would replace this capacitor first. You know, it's a crummy old one. It has this funny damaged spot on it, and this capacitor is responsible for me learning something really important. And it starts with me noticing this end of the capacitor has the words outside foil on it. You know, it kind of caught my attention. You know, what does that mean, outside foil? And I've been doing this kind of thing for 40 years, and I've never paid attention to it. So I read up on this. Thank you, Mr. Internet. It turned me into a genius here. I read up on it, and what I found out is it's simply the wire that goes to the foil that ends up on the outside of the spiral of foils and insulation that's inside the capacitor. And the reason it's important is because it can provide shielding, or you could think of it this way: it's not shielded itself, the way you want to look at this. So, because, you know, there's literally a sheet of aluminum or some metal just under this surface, that's true of all these capacitors, it can be affected by the various electrical fields that are in the radio. It acts as an antenna, basically. And so, here's the big trick about it. The big trick is, you want the foil side to be attached to the lower impedance connection, and that will reduce the effect that would happen if you were to attach it to high impedance. And a good example of a high impedance attachment point where this is important, and you know, I'm almost embarrassed to admit I didn't even know this. You really want to make sure you do not attach the foil side to a grid connection on a tube on a radio like this. Now, you know, I've had radios in the past that, and amplifiers too, that have hums I can't get rid of, and it's driven me nuts. And they're, you know, they're not the power supply, the low warm hum. They're buzzing kind of hums that are extremely annoying. And I didn't know anything about this. Now, I'm going to show you one of my new capacitors. It's very typical. Still a foil capacitor. Same basic construction as this guy, just a different covering, more modern, of course. Now it looks like this will last a long, long time. But look, there's no marking on the either end. When I look at the rest of the capacitors in this radio, you see the marking on the end of these. Look, even this one. You know, I've noticed this, but I've never paid any attention to it. So all the capacitors back at this time were marked, and the technicians and people working on it probably knew that that's important to pay attention to which way you put a capacitor. I've always thought, believed, heard that doesn't matter which way you put this. How could it matter? It's a capacitor. Well, here's a really cool trick I'm going to show you over here. It's on my scope here. I got to show this to you on my scope. So I make a little space right up here. Yeah, it's a little far away, but hopefully you can still see what's up here. I do a very simple experiment, and I think I'm going to be doing this from now on. When I'm installing capacitors, particularly in any high impedance situations. I don't want the outside foil connected to high impedance. So that's my scope. I've got it turned up to maximum sensitivity. That's why you're seeing all that on the screen just from waving this around. And all I'm going to do is just basically short the probe out with the capacitor. So here we go. Now I don't know which end's the foil end, but we're going to find out. And I'm just going to ground this end. And just stick it on that ground. You see the line has gone flat, of course. My sensitivity is 5 millivolts per centimeter. And now I'm just going to take my ever so powerful hand and squeeze this guy. Okay, and you can see the capacitor. I'm not touching the leads. If I touch the lead, you see it. I just squeeze the capacitor, and you can see a certain amount of signals getting into the capacitor. Now if I flip it around, try the same experiment. Oop. I think that's my hand down here on the probe doing that. Let's try it again. Okay, so here we go. I can see a little bit. You might not be able to see it up there on the... Let's flip it back the other way. Now I'm sure you can see that. So what that tells me is I now have the oscilloscope probe connected to the outside foil. And I best not attach this side of this capacitor to any high impedance connections, or at least I should try to avoid it. Try to make sure this goes to the low impedance side. That sounds like a really important thing. And you know, how have I gotten all this way without finding out about this? And thank you to the internet and the wonderful write-up somebody did explaining this and talking about this trick. I didn't invent this little trick. You know, I tried that with my voltmeter, and of course my voltmeter doesn't see millivolts like that. There's zero effect. You know, that's one of the coolest tricks I've ever seen. And I'll tell you about another, while I'm telling you about tricks, I'll tell you about another way cooler trick, and I tried it once, and it seems to work. And then you just take an audio signal. You can use music. You can use the sound, or the signal going to a speaker on a radio. And you just bring out one lead, ground it to the set you're working on. You don't have to do that. You can just bring out, let's say, bring out both speaker leads. And you connect a, you force the, oh, well, I got the story all wrong. Let me start over, okay? So you need a signal and a speaker. A separate speaker. So you could take the signal from a radio, it could be something like that. I'd use my tone generator. And you run the signal to the speaker through the capacitor you want to test. And you can do this right on the radio. You don't have to take the capacitors off. And it just takes a moment. And what you do is you just go capacitor, capacitor, capacitor. The bigger ones pass more sound. The smaller ones pass less sound. And the dead ones don't pass any sound. And it's so fast because you're using your ears. It's a wonderful experiment. I encourage anybody to try it. I've done it once and it worked. And I just really haven't had the occasion to do it again. Well, maybe this is a good occasion right here. Maybe that's what I'll do. But let's get back to what we were really going to do. And let's turn this radio on. Change that capacitor and turn this radio on. Let's move you up. You know, one of the things I really like about electronics is that there's a whole lot of smart people who have thought all this stuff out. And everything you see is very intelligent, in fact, and smart, and thought out. And I think that's kind of cool. Okay, make sure I put this in the right drawer here. 503. Okay. So, having noted now where the foil is on this one, and now that I know this trick, or technique, maybe that's a better word, eh? We'll call it a technique. We'll just see if we can just pop this guy out. It might not come off that easy. Pop. There he is. So that's pretty darn hot soldering iron. Turn it down a bit. Now that was not soldered on there very well. It was not attached very well. So I think this is a replacement. Give me a size. Tubular, made in Hamilton. Type 684. Capacitor. You know, I don't see any size marking on it. Oh no, it's under there. Let me, oh. Okay, I just gotta move you guys for a moment. Get my magnifier out. I think under a magnifier I'll be able to read it. It looks like 0.01. You know, and it does look like a 0.01 high voltage capacitor from back in them there days, 1932. Well, this isn't from 32, I don't think. Well, it looks more like 0.05. What I found in the past is you can just scrape the wax off and reveal the words. You scrape off the crummy wax here. Huh. Wow, this one's damaged. Yeah. Huh. I don't think I helped the case there. I could find it on the circuit diagram and identify it that way, which I may have to do, because if this is a replacement, maybe it's not even the right size. And you know, whoever put it in may not have known this whole foil thing, so even that might be foolish. And the worst situation of all is that I've removed it here and not really marked where I took it from. So usually what I do is I cut the leads, and the leads are hanging there. But I know it's this spot here. Close call. I've made that mistake a couple of times. You remove a component and look back at the circuit board and oh my god, where did I get that from? So not in this case. So if we take a look at where this was, it's from the switch. The switch is well, it's got this phono connection on the back. And I studied the circuit diagram for quite a while there, and I didn't see any switch for a phono. Yeah, see, that's been added in, I think. So I think this is some addition somebody's made. It just doesn't look engineered. Doesn't have the same screws. Doesn't look engineered quite the same as the rest. So I'm going to assume that this switch has been put in. Okay. Then what is this? That's why it's not on the circuit diagram also. Now that looks like an original wire though. Well, I'm just not sure, and what does it really matter anyway? Maybe I can trace back this way. Oh boy. Oh, there's all kinds of real old resistors in there. A few more parts than I realized. I just couldn't see them down under here. Other areas around here that are jam-packed with parts? No, not really. Pretty crowded down in here. Well, we could try testing it on my meter if I can get the leads into that. Let's give that a go. It's not the best thing to test an old component, of course, because it's old, if I accept the reading and the reading is actually off because the component is old, then all I'm doing is replacing it with another wrong size capacitor. So the leads are a little big for going into my meter here. I should have left well enough alone, eh? No, I can't get it to go into my meter. It's built for those little delicate leads. What a dumb situation. I find myself in another one of those spots there. Now, I'm just looking at it, I think. I think it's a 0.05. That's exactly what I had in my hand a moment ago when I was doing that experiment with. Uh-oh. I have to use my scope to figure out the foil end here. Now it could be in this application that doesn't matter. So that's quite likely the case. But I can't be sure. So having learned the technique here, just bear with me. I won't put it on camera. I'll just go ahead and figure it out here quickly. Okay. Goes in this way. I guess an interesting thought would be this radio's been around since 1932. 1932, nobody had record players in their homes that required phono plugs. I'm pretty sure of that. So somewhere down the line, 10, 20 years later, somebody saw fit to add a phono plug and did this circuit change. Installed this switch here, I guess. You know, this wire may have originally traveled up to here and they've simply brought it down and stuck it down there. Well, that didn't work. Still didn't work. What's going on? Hey, I thought I'd just take a moment. I'd just change that capacitor. Ba-bing. You know, it did solder part of the wire. So let's just put a little more. Let's just give her, as they say in some circles. There we go. Anybody see my jukebox video from earlier today, where I didn't put the work on video, but I spent about probably 15 minutes discovering through a troubleshooting process that the jukebox had been turned off via the master switch. I said, wow. So all I had to do was just turn it back on to make it work. So I think those things are interesting when they happen. I often stop and think, well, how the heck did that happen? How did I end up spending 15 minutes discovering that it just required the switch to be turned on? And so the answer to that particular question is, well, the switch is in a place where you wouldn't expect anybody to ever touch it. So it just never crossed my mind that anybody ever touched it. And I still don't know who or why somebody would turn the master switch off. As far as I know, that jukebox has been playing non-stop, or has been on non-stop for about 12 years. The people who run the restaurant didn't really know much about it and just never touched it. They just left it plugged in 24/7 for 12 years. Of course, I mean, it would go off occasionally, power outages, and I suppose once in a while they unplugged it to move it somewhere or something. I don't know. But so, you know, the thing is, troubleshooting is tricky business because although there is a process to it, there's many approaches to it, and if you're lucky to pick the approach that finds the problem quickly, then good for you, but you could easily go off into the woods and wander around for quite a while. And I'll tell you what the worst thing is, just before we turn this guy on. And what is the worst thing? The worst thing is forgetting what you were about to say. That's the worst thing. The worst thing is making an observation wrong and then carrying on beyond that observation because you have no tendency to go back and check it. And, you know, that's basically what gets me into the forest, I think, in most cases. Okay, enough talk. Let's turn this thing on. Let's see what happens. And the reason I'm willing to turn this on is that the owner had it on just before he gave it to me. And this report was all the tubes lit up. Okay, it's a good report. I'd be more cautious if I didn't know that he had operated it. So, now I apply power through my power control box, which you can't quite see here. Okay, so now you can see it. It's just this box here. And I always apply the power limited, of course. I limit it with a light bulb.